There's a first person on the stream, so that means we can get started. I wonder if it's Vincent again. Do come say hi in the chat. Today, I think I'm gonna keep it short. Yeah, today's exercise seems pretty doable. No more fun VM stuff. We're just back to number crunching, but that's fine. Yeah, yesterday's puzzle, don't want to say too much about that. Most of the solutions I saw are all fairly similar. I think the big difference was that some people used an atom to keep the state of the machine, whereas I did everything functional, just in a loop recur. Yeah, but let's see what we have today. Before I get to today's puzzle, few questions. So another person asked what font, what theme, and what editor am I using. I really should put these in an FAQ. But as mentioned before, the font is Iosefka. The theme you're currently seeing is Tomorrow Night. I kind of switch between a couple different themes. I also use Tomorrow Day if I want a light theme in kind of the same style. I've also used Solarized. I think that's a pretty cool theme. And lately I've been using Löwe. I just think it's a lot of fun that a pretty nice theme is named after a small city close to where I'm from. It's also the place where we had Heart of Clojure last year. But I like Löwe because it's a good theme that still looks good when you're using Emacs in a terminal, which we do sometimes when we pair. We log into a machine in the cloud somewhere, launch up tmux, start Emacs in there, and then multiple people can connect to the tmux. My editor is of course Emacs, although some people might think that it's Vim, but no, it's Emacs with Evil, so with Vim simulation. Of course, Cider's in there for the Clojure stuff. I use paredit for the Lispy stuff, and all of that you can find in my Emacs setup, which is called Corgi. All right, that answers the questions. Let's see what we have for today. So a lot of people speculated that we would continue on this virtual machine that we started building yesterday. I kind of had my doubts because if you look at the story, yesterday we were sitting next to a kid and it was his handheld gaming device that we were poking at, and we're not going to be on this flight until Christmas. Now maybe he'll run into other people that have similar devices, but today we are still on the flight, but we turn our gaze forward to the in-flight entertainment system, where apparently there's a little open data port. Non-standard, but cheeky little elf uses some paper clips to hook into it, hack into it. And I guess it's some kind of serial port, we connect to it and we just start getting numbers. But it's using, we figure out that it's using a well-known but weak encryption scheme or cipher scheme called the Exchange Masking Addition System, or Christmas. And basically it's a sliding window. So you can already see that we're going to be using a partition, I think, with a step size of 1. So it says, okay, it starts by transmitting a preamble of a 25 numbers. So we kind of, we take the first 25 numbers, keep those aside, and then we start looking at each number in turn. And each number needs to be the sum of 3 numbers in that preamble. So the example they give, say that the first numbers are 1 through 25, then 26 would be a valid number because that's 1 plus 25, and 49 would be a valid number because that's 24 plus 25. But 100 would not be valid because you can't pick 2 numbers between 1 and 25 and have them sum to 100. 50 would also not be valid because you can't use the same number twice. So you need to pick 2 unique numbers from the previous set. The 2 numbers in the pair must be different. So I guess even if a number occurs 2 times in that preamble, you still can't use it twice. Now, after this, once we get to the 27th number, basically the first number drops off and we add the first number after the preamble, so that 25 numbers becomes kind of a sliding window. At least that's how I understand it. Suppose the 26 number is 45 and the first number, no longer an option as it's more than 25 numbers ago, was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 to 19, not 20 because that was the first number it dropped out of the window, 21 to 25, or 45, the next number in the sequence. I think this is not going to be particularly hard. Let's grab some demo input. Stick that in there. Just gonna boom, 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 boom. This is capital J. I think that's a standard Vim thing. In Emacs, I would do meta caret on the lower line to move it up to the higher line. Yeah, we have some input. And then I'm first just going to write a little valid helper function where we have a window and a number. And I guess we kind of do the you know, same thing that we did before, right? Like Cartesian product of, no, not of num, of the window. So we use for to sort of take the Cartesian product of those two with the condition that they're two different numbers. And I guess also, actually, if we take the condition that x needs to be smaller than y, that means that we don't get the problem that each pair occurs twice. And it also immediately means that we get two different numbers each time. So I think that should be good enough. And then we just add those two together, plus xy. So there's our little for loop. So yeah, to demonstrate what that already does, say we have 1, 2, 3. Ignore the second one for now. We get 3, 4, 5. So 1 plus 2, 1 plus 3, 2 plus 3. I think that makes sense. And then we just need to do this, which is kind of a common Clojure idiom for checking if a value is in, you know, any random sequence. So if this, I mean, we could also, you know, jam this into a set. A set would allow us to use contains, but this is a common thing that confuses people. Contains works on sets. It works on maps because then you can check for a certain key. It works on vectors, but then it doesn't check for the value in the vector. It checks for the index. So you can say, you know, 1, 2, 3. Well, let's give a better example. 999. Does this vector contain 9? No, it doesn't, because it contains indexes 0, 1, and 2. So watch out with contains can be quite confusing, but that's how it works. That's what it does. If you do want to check for a certain value in a collection, then the Clojure idiom is to use a map literal. And that's cool because that also means that immediately, you know, you can check for either or, right? Like, does this contain a 7 or an 8? Now it doesn't, but now it does. And then, yeah, you get the value back. That's truthy. Sometimes you might want to use that value itself. So that's valid. So then we take our demo input and we're just going to partition it. So for the demo, the size of the window is 5, which means that I'm actually going to take a partition size of 6, but a step function of 1. So that gives us, is it the other way around? N step collection, yes. Yeah, sequence operations, the collection or the sequence goes last. So then we get this. Yeah, That, I think that's right. And yeah, what's the question exactly? We need to find the first number that is not valid, basically. So let's also do a for loop here. And then say the part, whatever. And then I'm gonna split that up. Say my window is but lost. So everything except that last one, whereas the number that we're currently checking is the last one. So that's why I'm taking a window size of 6, even though, you know, we need to check a window of 5, but we're taking the 5 and then using those, we check the next number. And then when not valid window num, then we return num. We just need to find the number, right? What is the first number that does not have this property? And yeah, let's just do a sum identity over this so we just get the first truthy value in this sequence. Nil. Interesting. And what are we supposed to get? After the 5-number preamble, almost every number is the sum of 2 of the previous 5 numbers. The only number that does not follow this rule is 127. So that's this case. If someone sees what I'm doing wrong, do tell me on the live chat. So valid. Oh, did I not reevaluate this? Ha. 127. Okay. Defend Christmas cipher. Input preamble size. And then, so to make this generic, we increment the preamble size. Oh, I need to slurp this. Yeah, I have. So there's a couple I was talking about that I'm using, you know, evil and sort of the Vim style bindings. The main key bindings that I have for day-to-day editing that are not standard Vim, I use smaller than and greater than for slurp and barf. So this is greater than, smaller than. I think in Vim they indent and outdent, but I use aggressive indent, so I never have to care about indentation. And then capital L and capital H go forward an as expression or backward an as expression. And so this is fun because then you can do stuff like, you know, 2D capital L to, you know, basically cut two as expressions, stuff like that. So these are Vim, what they call them, text objects for as expressions, which is extremely valuable. So does our cipher work? Christmas cipher demo input. That's fine, Mitesh. I'm not gonna tell anyone. So now the preamble size is 5, so we should get 127. So far, so good. So let's fetch the input. We're already on day 9, huh? Fascinating. Yeah, I should really start creating a util namespace here. Like we talked about yesterday, let's do this properly this time. Say with open reader, that's it's often abbreviated in these APIs to RDR. And then puzzle input. Actually, let's use a format, and I can say % 0 to D, I think. Let's see, does that work? Yes, puzzle input 9, so puzzle input day. We have a reader, and then we take a line seek over that reader. I also have this parse long helper somewhere, which is really just wrapping that, but then I can say map parse long. Gonna stick a do all here to make sure we read everything before the reader closes again. Add that one, yeah, looks better. Copy that namespace name, go back to puzzle 9. Require as util. Def input util resource seek for day 9. Boom. And there are our numbers. So now when we run our Christmas cipher on the real input with a preamble of 25, we get this. So far so good. First star for the day, and then let's move on to part 2. The final step in breaking the Christmas encryption relies on the invalid number you just found. You must find a contiguous set of at least 2 numbers in your list which sums to the invalid number from step 1. Again, consider the above example. In this list, adding up all of the numbers from 15 through 40, yeah, that's the one they highlighted here, produces the invalid number from step 1, 127. Of course, the contiguous set of numbers in your actual list might be much longer. To find the encryption weakness, add together the smallest and largest number in this contiguous range. In this example, these are 15 and 47, producing 62. What is the encryption weakness in your Christmas encrypted list of numbers? Right. So yeah, in the example input, we found 127, and then we need to go through the input again to find these. Yeah, let's see. Let's just do maybe a loop recur for this one. I mean, I always like, loop recur is a little bit of a bailout, like get out of jail for free. You can do anything with a loop recur. There might be more elegant ways to do it. But my idea is basically to say, so yeah, first of all, we have a target of 127. Let's put some stuff here so we can then like later just pull that into a function easily. Demo input of demo input, and then yeah, input, and then we're just sort of gonna do next on that. I kind of want to do a take while, but the problem with a take while is that we only get one number at a time. I mean, I can do another loop recur. So let's say we start with, or maybe I do a 4. Can I do a 4? I don't know, just kind of winging it here. So let's say if we say take take nums count and then sum those together. All right. And then we kind of have, hey Vincent, welcome on the stream. We have a couple different options. So maybe the sum is the target. And then what do we need to return? The smallest and largest number in this range. So then we return apply min. Well, let's range. Do you ever pick your variables just so they have the same length, so they line up? I would never do that. No, absolutely not. That is so arbitrary and so satisfying. Yeah, so this is our terminating condition. Now the other option is that our sum so far is smaller than our target. Actually, I can't. Can I do? Because I can't recur from here to the outer loop, but I guess I'm going to break out of this loop. We'll see how we get there. I don't know what I'm doing. I had a very clear idea for the first exercise, and the next one, maybe I should like stop the stream for 5 minutes, but I'm not going to do that. Just going to see where we get. So if it's smaller, then we still need to continue recurring, right? And we basically just increase the count. So we take one more number from where we currently are. Oh, by the way, this is of course intended to be inside a cond. Yeah, so we recur with one more. So now we look at two numbers, then we look at three numbers until either you know the sum equals our target, or we have blown past our target. So that means that if we just do it like this, that means that this loop is either going to return nil because no condition matches, which is basically the third case here, right? That sum is now greater than our target. By the way, a little trick. So like people find it, this is, and I've struggled with this too, right? That like prefix notation is all fine. Like it makes a lot of sense in case of a plus. But with these comparison operations, people find it harder to reason about. A little trick that I have adopted over the years is to always prefer the smaller than. So, you know, instead of this and turning these, swapping these, use the smaller than, and then basically what you're checking is that the things in here are in increasing order. So, you know, think of this as kind of a shape saying, you know, you're going from small to big. So, you know, if I put some more here, it basically means that like each thing in this list here is bigger than the previous thing. Each next thing is bigger than the previous thing. So it kind of, you know, like imagine them kind of having this shape, you know, going from small to big, and that's the shape that this thing has. So little mnemonic there. Don't know if it helps anyone. Right. So then we are here. So this loop terminates. Let's call this result. Very unimaginative variable names. Right, and then here we also have a couple. Well, we basically have two options, right? Like either this returns nil, either result is nil, or it's a vector. So if res is a vector, then just return it. If not, then we recur with next nums. Here's a suggestion. Wait, need to make this okay. Good. Proceed with using partition like you've done in Christmas Cipher, but in part 2 we just have varying window lengths and only need to check for the sum. Yes, I guess so. But you'd still, I'm just not 100% sure about the loop where you would vary, you know, how you would vary that window length. I mean, I guess you could do a loop recur for that. But I think we're there, actually. What does this say? No. Clojure line persistent vector cannot be cast to a number. I guess that 2-element vector we're returning somewhere. Wait. Oh, no, I just have my take swapped. Yes. 1547, that is our answer. Target input. So yes, 1547. So let's put this number in there and the real input, and we get this. What is the and then we need to add these together. Okay, can do that here too. Yeah, here, since I was talking a little bit about the Vim style editing, what I did here is using something from Vim Surround, which you can also get with Evil Surround. So I'm saying CS smaller than, so change surrounding round brackets and change them into square ones. So these are the four things I typed. Change no, wait, the other way around. Change surrounding square brackets, turn them into round ones. CS like that. Here you have to type the closing one. If you type the opening one, then it puts some extra spaces in there, which is usually not what I want. So yeah, little Vim/Evil tip for you right there. What do we get? Oh, did I not evaluate this? Already takes a little bit of time. I wonder how other people, sure, there's all kinds of optimizations you can do here. Over half a second. Unacceptable. But it's correct. All right, nice. Glad we managed to cap it under half an hour today. Do leave your comments in the comments. Share links to your solutions if you think there's anything interesting I should talk about tomorrow, or if you want feedback on your solution. And hope to see y'all on the stream tomorrow. Have a great day.